Hi everybody, Charles from GMAT Ninja here. Welcome to our episode number 5 of our reading comprehension series 2026, always doing this live. Today we're going to talk about science passages, but not just science passages for the sake of it. I'm going to give you the science passages that are just walls of facts, or at least just feel like walls of facts. So if you are not new to these videos, if you've watched us talk about reading comprehension process, either on the GMAT Ninja channel or here at GMAT Club, you'll hear us kind of talk about, look for point of view, think about purpose, think about structure. And that's a huge, huge part of what it takes to be consistently great at reading comprehension. Now, a lot of people get really thrown off when they see a topic that doesn't obviously have a lot of structure, right? So if the passage is just something that feels like a wall of facts, feels really dense, it's really easy to get kind of knocked out of your habits, knocked off your perch a little bit, and you start doing things differently. And we see a couple different manifestations of that on passages like these. Either you start just obsessing over every detail and just staring so intensely at every little thing in that passage, you miss the big picture. And I will say that in the two passages I've chosen here, they're both really tough passages. There still is a big picture. And if you're gripping too hard on the details, you're going to get yourself into trouble just as you would on any other passage. That's one thing we see. The other thing we see is people just go, whoa, whoa, whoa. I don't know that much about science. What's going on here? This is terrifying. This is intimidating. And they just start skimming or they do something to undermine their reading. So as with everything else we do, it's all about consistent reading. I want you to fight for purpose. I want you to fight for point of view. I want you to think really hard about all that stuff as we go. And spoiler alert, it's hard to see in these. And some of the questions, you do get in the weeds of details. But if you understand broadly the argument the author's trying to make and how they've put it together, it's going to be a lot easier to make sense of those details, even when they're buried really well, which they are in a couple of these questions. Okay. Getting some great questions. Great question already from the live group. Here's what I'd like to do. I'm going to go ahead and throw this passage at you. Let's go ahead and get started on it. It is just a one paragraph passage. So again, it just feels like a big old wall of fact about quantum tunneling. So a little bit intimidating. Hey, if science isn't your thing, don't get intimidated. It is never the case on the GMAT. There are never passages that pre-assume any knowledge of science or anything else. So if science isn't something you studied a lot of, don't worry. If science is something you've studied a lot of, probably isn't an advantage here. So big paragraph long, wall of facts, kind of intimidating. Do your best with it, break it up where you can. And then after we're done with the paragraph, we'll talk about it. And I'll also answer some of the great questions again from the live group. Live group, if you have questions, keep popping them in there. And as soon as you have your thoughts on what this passage is about, really, and what the purpose is, what the structure is, please fire it into the chat. All right, go and take a moment. And I'll get rid of that banner. Live group, I'm going to give you about 20 more seconds. Please toss your reactions into the chat, even if you're just going, WTF, I have no idea what's happening here. That's still helpful. All right, if you needed a minute, go ahead and take it. So again, I said at the beginning of the video, these are about as hard as they come. I'm deliberately giving you the most challenging walls of facts I can find, and this is one of them. So again, it's really hard for me to find anything that is more fundamentally difficult in terms of science passages on the GMAT, both because the language is tough, the concept I think is challenging, and also because it just kind of reads like fact, 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 fact. And what do you do with it? How do you think structurally? Thinking structurally is the key to making sense efficiently of these passages and cutting through questions efficiently. How do you do it here? And great question, Yo-chan. Not sure if that's how you pronounce it. So yeah, I mean, you're basically anticipating what this whole video is about. And so here's what I would quibble with a little bit here. So I'm trying to give you the passages. So I chose 2 passages that are the most fact I can find. But there's always something. There's always some sort of structure there. There's often a tip off of some sort of point of view. It's not as strong here as it is in most of the passages, right? Vast majority have far more point of view represented than this one does, or the second passage we'll do today. But there's still some. And I want you to look for that structure and think about, okay, how is this passage organized? Does the author have a main point? Maybe that point isn't obvious. I don't think that main point is obvious here, but I would argue very strongly that there is structure, and we even see a little time. And the more you fight for those things, the easier it is for you to catch the big picture of what's going on. And then as they start asking you about details, which is what's going to happen on these pretty darn difficult questions, you're in much better shape to find the right detail, put it into context, slice through the question efficiently. So awesome question. And again, I also want to be clear, passages that are this dense, that are walls of facts like this, they aren't that common. Do they exist? Of course, here's one. But they're not that common on the GMAT. Usually there is a lot more kind of nuance and to point of view. Sometimes a little more conversational, less fact dense. All right. So the thing that jumps out at me right away as I read this. So again, I'm always trying to be tuned into point of view. Do we have an author's opinion? Look at that first sentence. Most attempts by physicists to send particles fast enough to speed of light involve a remarkable phenomenon called quantum tunneling. And then what I see here is the author kind of going on to sort of go through the history of that theory and explain how it works and we come up to the most recent data. Personally, I see a little bit of, so whenever I have these 1 paragraph walls of stuff, I'm always looking for a natural break just for my head so I can, and again, sometimes it's not there, sometimes it's not obvious, but it kind of feels to me, so again, you can't do this on your page, it's on the screen as one blob, but in my head, I'm kind of going, wait a minute. As you see that word, though, it seems like something's turning there a little bit to me. That first part is, okay, the author is introducing this idea of remarkable quantum tunneling. So we've got a little opinion there. How much is it going to matter? Maybe not a ton here. But the author thinks, hey, it's remarkable that this happens. I mean, you can't throw a ball through a wall, right? But somehow subatomic particles can go through a barrier. And then the whole thing is about what happens as those quantum particles go through barriers and how fast do they go and all of that. And then I think it goes through kind of chronologically. So is that the clearest way to present an argument? A lot of reading comp passages, it's something other than just chronological, right? The author says, oh, here's one person's theory, here's another person's theory, and here's which one is right, or here's a third theory that's better. This is less clear in a way, right? It's just chronology, but there is still some sort of structure. The more you can grab hold of that, the better off you are. So the first thing I noticed here, so 1932, right? So the extreme rapidity of quantum tunneling was noted as early as 1932. Okay, so we'll say quantum tunneling noted in 1932. And then it says, well, not until 1955 was it hypothesized by these guys, Wigner and Eisenbud. Be a really good name for a marijuana store in Colorado. Wigner and Eisenbud hypothesized that tunneling particles sometimes travel faster than light. Okay, so in 1932, it's kind of noted that the speed of tunneling is a possibility. We've got 1955, we've got Wigner and Eisenbud, and they say maybe faster than light. And again, just a hypothesis, right? And then they kind of get into the weeds here. And it's kind of up to you. And I think it's individual taste, whether you want to look at this and go, okay, I'm going to really dive into the details there about how it is that they got to this speed of light thing. I think it's a little dense. I think it's a little bit hard to get to. I don't necessarily want to say too much about it right now, but it's this idea that, okay, well, there's a piece there that makes sense, that's obvious, right? The thicker the barrier, the longer it's going to take to go through. Then there's the part that makes me go, wait, what? Then somehow the tunneling time hits a maximum and the barrier can keep getting thicker and the time is still the same, which seems totally counterintuitive. And that's why it can go faster than light. And that kind of makes sense, right? Because if somehow this particle, so the time to get through this barrier hits a maximum, and then after that, it's still getting through at that maximum time, you could have a barrier that's several kilometers thick. And if it's still going through in that time, it's going to be really, really fast in terms of its speed. Okay. That kind of makes sense. I mean, it's counterintuitive. I guess it's remarkable, but I guess I have my head around that. Good enough. So we've got 1932, quantum tunneling is noted. 1955, these guys, Wigner and Eisenbud, say, I think they can go faster than light, and here's why. And then more recently, and I think it's vague on the date here, so more recently, we have these researchers who say, yeah, I mean, yeah, they can go faster than light. And you've got this guy, Raymond Chow and his colleagues. So I'll just call him RC. And his colleagues said that, yeah, photons, they proved it experimentally. So photons, do you know what a photon is? Does it matter? Not really. It's probably some subatomic particle. If you've never heard of it before, fine, it's a particle, right? It's got to be. We're talking about particles here. Through a filter at 1.7 times the speed of light. Okay. So now we have structure. Look, one other thing I'm going to say here is that everything that we try to teach you, rest of the GMAT Ninja team, if you ever watch the rest of our videos on our channel, all the things I do in these live videos, in a way, you can think of it as these are tools to help you engage more deeply. That's really all it is. But not too deeply, right? Engage deeply, but efficiently. That's what we're always going after. So is there magic to this structure? Oh, hey, well, this structure, it's really important for you to memorize that this is a chronological structure and that's something that appears. No, that's not the point. It's just something where you recognize what the author is doing. It helps give you these checkpoints to go, do I understand this situation? Author says quantum tunneling is remarkable. It shouldn't work, but it does, right? Can't throw a ball through a wall, usually. Here's the chronology of how researchers discovered really how it works and even showed that it's possible to send something through a barrier at 1.7 times the speed of light. All right, cool, we got it. Now that whole technical bit about why the tunneling speed gets faster and faster as the barrier thickness increases, the argument I'd make about that is if you struggle to get that sort of detail, but you still understand the big picture here, it's okay, you're good to move on because they may or may not ask you about that detail. Spoiler alert, they're going to, but they may or may not. So it's okay to move on from that if you're struggling. The other argument I might make, though, so yes, it's okay to move on if you really have a hard time getting your head around a detail like that. Just keep going as long as you get the big picture. It's okay. And I would also make the case that if you're really reading in an engaged way, try to make this stuff interesting for yourself as much as it can be and see if you can get your head intuitively around what's happening. And it helps a little bit if you can do that. All right, all kinds of thoughts from the group. Not sure if we want to address any of these on screen. Difficulty of the passage depend on the current scoring, or is it just the questions that vary? I'm not totally sure I'm interpreting your question right. But passages are written with some number of questions attached. On the actual exam, you'll always see 3 or 4 questions at a time with a reading comprehension passage. I think sometimes there's certainly variability among those questions. And depending on how you're performing on the exam, they will give you a set of 3 or 4 questions that is tailored roughly to your performance up to that point. So does a passage have its own difficulty level? Technically, no. The difficulty level is assigned to the questions, but when you think about what you're actually being served, it's a little mini test of 3 or 4 questions with a passage. That does have an average difficulty level, and that's the thing that is adapting based on your performance up to that point. And I hope that answered your question. If not, feel free to follow up. Awesome. Thank you so much. I always really appreciate that. Yes. So this is something that, thank you for asking this, because I talk about this in the first episode, and I probably need to come back to it more often. A lot of this business of taking notes, so it's very much a personal decision in some ways. Here's what I insist on. So this process that you see me do on the board, in all honesty, I'm writing a little bit more so that you can follow my thinking. I'm probably writing a little bit more than I typically would if I was taking the test on my own. What I do feel really strongly about, though, is stop at the end of every paragraph and go, why? Where's the structure? Where's the point of view? And try to give yourself, whether or not it's on paper, try to give yourself these checkpoints to say, hey, can I put together the structure? Do I understand the argument? Do I understand the points of view? Do I understand how paragraphs fit with each other? In this case, we just have one paragraph. I mean, I broke it up for you, but that process is what I care about, is that you're stopping and going, okay, why? Where are the points of view? Where's the structure? Where are the turning points? Do I understand this without gripping too hard to the details? Now, for a lot of people, it really helps to take notes. And I think my notes here are a little bit on the wordy side. And again, I'm doing that in part just so that you can follow my thought process. 8 to 12 words per paragraph is sometimes good for people. A little bit more is okay. But it's a personal call in this sense. If it helps you to write it down and that helps you engage, please do it. Just make sure that they're engaged notes that are engaged in purpose, structure, point of view, opinions, connections between paragraphs, and not just, hey, I'm scrolling random notes the way I might have done in a lecture in university that I wasn't interested in. I'm just writing random stuff because I'm not really paying attention. Don't do that. Random notes are bad for almost everybody. Engaged notes are good for some people. Engaged notes aren't good for everybody, though. What I mean by that is some people are more kinesthetic than others, meaning that if their hands are moving, they have an easier time learning and engaging. So my wife, for example, when she was in grad school, she's a former lawyer, different color highlighter between every finger. She would highlight every word in her textbooks. And I was like, what are you doing? Are you color coding it? She's like, yeah, but that's not the point. What do you mean? That's what helps her engage. She puts her hands down. She's not moving. She can't think. If you are like that and your hand needs to move, write more notes. That's fine. Definitely write notes. Other people, they start writing notes, they disengage. So experiment a little bit with it. If you have more than this in your notes, you're probably overdoing it. If it's less than this, probably okay. But then experiment on your own and just say, am I better off doing this in my head, or am I better off writing it down? That's the part that's going to be different depending on how your brain works. Experiment, track the data, see how you perform better with and without notes. Okay. All right. Let's get to some questions. Go ahead and have at it. And live group, as always, as soon as you have something, fire it into the chat, please. All right. Live group, awesome. And this is your warm-up. Easiest question I'm going to give you today, statistically at least. So author of the passage mentions calculations about tunneling time and barrier thickness. Why? A, is it to suggest that tunneling time is unrelated to barrier thickness? Nope. That's exactly the opposite of a lot of the point here, is that thicker the barrier, faster the speed. So A is definitely out. B, explain the evidence by which Wigner and Eisenbud discovered the phenomenon of tunneling. No, they didn't discover the phenomenon of tunneling at all, right? It existed before that. That's what we see structurally in the passage. It was noted in 1932. These two just took the theory a little bit deeper and attached it to the speed of light, said, oh, maybe they can go faster than the speed of light. C described data recently challenged by Raymond Chiao and Associates. Not at all, where nothing in the passage challenges really anything. I mean, it's kind of building on it, but Raymond Chiao and his colleagues are not challenging any of the data at all. That's not what we're doing. D, question why particles engaged in quantum tunneling rarely achieve extremely high speeds. No, not at all. I mean, kind of the whole point is that they can achieve these really high speeds. It is rare, but the point, that's not the point. That's not why they're mentioning the calculations about tunneling time and barrier thickness. It's to show that it is possible for that speed to be faster than the speed of light. I really hope we like E. Explain the basis for their hypothesis. Exactly. That's exactly why we're talking about it. It takes to explain the basis for Wigner and Eisenbud, who said these particles can go faster than the speed of light. All right. Great work by the live group. Any questions I should address here? Ooh, something's weird. I've lost a lot of your comments, guys. Okay, having a little glitch. Apologies if I'm missing some comments in there. If there's something that you want to ask live group and I'm not addressing it, please fire it back in there because some glitch just cut off all but the most recent 8 comments. So apologies for that. All right, one more question. Go ahead and take a minute. Live group about 20 more seconds. If you're flailing, please toss that into the chat too. I'm curious to see that. Okay, looks like the live group's pretty comfortable. If any of you guys are struggling on this, let me know. This is a question about half of students miss. So if you are struggling quietly, no shame in that at all, because these last 2 questions are really tough. About half of people miss them. I think a lot of the ones who get it right are kind of struggling. But again, and I know I'm a broken record on this, if you've gotten the big picture out of this and you kind of understand sort of how these theories have evolved, you're going to be in pretty good shape. So this is about this business of, okay, well, if the tunneling time reached no maximum thickness, no maximum in increasing with barrier thickness, then what would be true? So if you kind of go back to the chunk of this that's in kind of about 2/3 of the way through the passage, what are we saying about all this? Well, okay, so the speed reaches a maximum. The barrier can keep getting thicker, but the time is capped, which means the speed keeps going up. This would imply that once maximum tunneling time is reached, tunneling speed will increase without limit. Okay, so what happens if there isn't a maximum time? What would happen then? A, would tunneling speed increase with barrier thickness? We don't know. Maybe it would still increase, but it wouldn't increase limitlessly, right? But we definitely can't support A here because we don't know whether or not it would increase. Maybe if you didn't have a maximum time, maybe it would decrease, maybe it wouldn't, who knows? Maybe it would be a constant, we have no idea. B, tunneling speed would decline with barrier thickness. We can't prove that, right? We don't know what would happen without this. We just know that it wouldn't increase limitlessly D is out. C, tunneling speed would vary with barrier thickness. Still don't know that, right? It's possible that it would vary. It's possible it would be a constant. We don't know. All we know is it wouldn't be a limitless increase without this maximum time. It's exactly what D says, right? Tunneling speed would not be expected to increase without limit. A little bit of a murky sentence. Like, I think if I'm under time pressure, I would look at that and go, like, wait, what? Tunneling speed would not be expected to increase without limit. Yeah, that's right. Because if we didn't have that limit on the time, then it wouldn't be possible for this to increase limitlessly. So D is looking pretty good. And E, successful tunneling would occur even less frequently than it does. We have no idea. There's really nothing in here about the frequency with which tunneling occurs. It says that there's a probability, it's a small probability, but we don't know if barrier thickness or if this business of time, we don't know if that time limit is related at all to the success rate. So E is out. Yeah. And our answer is D. And man, StreamYard, I apologize, guys. StreamYard's acting up on me a little bit here, the software we're using. So I keep losing comments and, oh, they're coming back. Okay. All right. One last question on this, and then we'll hop to a longer passage. Gonna take a moment. And if you need more time, hit that pause button. Yeah, again, hard question. Um, the thing I keep saying, read for structure, blah, 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 blah. Shut up, Charles. It really helps here. And some of these tough questions on these tougher, detail-y, wall of fact kind of passages, yeah, sometimes it's really hard to get in there and understand exactly what's going on. I think this is a good case of it where it's like, if you've done your work here and understand the passage well, it's going to help you enormously to find what you need. I still think it's hard to spot, even when you know where to look. So earliest scientific investigators of quantum tunneling, what can we infer about what they would say about it? Well, we know the first mention we have is these 1932 investigators, researchers, something. We don't know who they are. It doesn't say anything. So about halfway through the passage, though the extreme rapidity of quantum tunneling was noted as early as 1932, not until 1955 was it hypothesized. Now we're off to Wigner and Eisenbud. So what do we know about these 1932 guys? Nothing really, except as you really look at that sentence carefully, not until 1955 was it hypothesized by these other guys, that the tunneling particles sometimes travel faster than light. Okay, that was the first time, 1955, Wigner and Eisenbud, first time anybody had thought, oh, wait a minute, maybe these go even faster than light, and then we get into the barrier thickness stuff. It's really all we know. They didn't know they were going to go the speed of light. They didn't think of that, these 1932 guys. It's really all we know about them. They knew that quantum tunneling was possible, or they noted it, whatever that means. And they didn't think it would be speed of light. That was an idea that came up 23 years later. Okay. So A, did those early researchers find it difficult to increase barrier thickness continually? I don't know. I don't know anything about that. B, they anticipated the later results of Chow and his colleagues. No, because the 1932 crowd didn't realize that that going faster than the speed of light was a possibility. Raymond Chow and associates proved that you could go faster than the speed of light. So definitely not B. C, they did not suppose that tunneling particles could travel faster than light. It's really the only thing we know about them. So C's looking pretty good. D, they were unable to observe instances of successful tunneling. We don't know that either. They noted that tunneling was possible. Could they observe it? I don't know. Maybe they could, maybe they couldn't. They made use of photons to study the phenomenon of tunneling. I don't know. Maybe they did, maybe they didn't. We don't know anything about them other than it was the guys later who hypothesized that going faster than the speed of light was possible. So C's our winner. Okay. That is it for this one. Just checking through some of the comments real quick. Passages. Yeah, great. Okay. Seeing good variety of the live group. Again, really tough question here. So if you struggled on it, absolutely no shame. These are questions about half are getting wrong. Next passage. It's going to be kind of the same deal, guys. These, I guess I'm supposed to do this. If you're enjoying this video, you want more of them, free GMAT course, do the thing with the QR code. We're around. And if you don't like me, then there are people that we hire that do videos better than I do. So go watch those, skip the ones with me in it. All right. Next passage here, asteroid collisions. Okay, I am seeing some really good questions suddenly that are popping up. And I apologize for delays, live group. There's something goofy with the comment feed today. So things are showing up a little bit later. Yeah, great question here, Maria. And thank you. Great to see you here again live. Yeah, this you could argue here that this is a little bit of a sloppy thing in the question. Do we know that the people in 1932 were the earliest investigators? Maybe somebody was doing this in, I don't know, 1920. It's possible. But given what we have in the passage, who are the earliest investigators we know of? We don't know who they are, right? But it was as early as 1932. Somebody was studying this around then. That's the earliest we know of. I suppose we could quibble with the question and say this would be stronger if it said the earliest known investigators, known and scientific investigators. But it's all we've got, right? So what can we infer about those people? This is it, right? So we have the first time when this was noted, around 1932, noted that quantum tunneling was possible. They weren't thinking about speed of light back then. Is this bulletproof? You've got a point there. We can argue that it isn't, but I don't want you to overthink that. It is so clearly better than the other four answer choices. Because Maria, by the way, I really do think you have a point here, because yeah, maybe somebody was doing it earlier. But if that was the case, then it seems reasonable, at least, that anybody earlier than the 1932 crowd also would not have been thinking about the speed of light. And we know that from the language, right? Not until 1955 was it hypothesized that the particles sometimes travel faster than light. So we know that those earlier investigators were not doing that because it wasn't done until 1955. So even if somebody was doing this in 1892, they weren't thinking about speed of light based on the language in the passage. Could the question be tightened up? Probably. Is C still the best answer? I would probably argue, very much unambiguously here. Okay. One other general thing. This is worth talking about for a moment here. And I'm gonna, Lucario, and again, apologies for mispronunciations. I want to address this. I'm going to do it specifically through reading comp video. A couple things are possible here. One is that the two most likely culprits, and this is something that happens all the time. When you read the comments, let's say the things people write in the shared GMAT experience section of gmatclub, or sometimes you see this kind of thing on Reddit. When somebody says, I crushed the GMAT, I got a 755 after 23 minutes of studying. Well, that's the thing that gets upvoted and gets lots of comments, and it's at the top of the feed. And for every one of those, there are dozens of people who are sitting there going, I walked out of my exam and I was disappointed, and I don't know what happened. It felt different. When it felt different, usually there's one of two things going on, or a combination of the two. One is if you have relied disproportionately on non-official materials, sometimes you get to the real exam and it feels different. Possible, right? So people and again, no shot at any test prep companies. Realistic questions are really hard to write. GMAT, the creators of the GMAT, they spend thousands of dollars literally on each question. It's really hard to mimic the style perfectly. So if you're relying on non-official materials, then sometimes you get to the test and go, whoa, this felt different. All right, that's one factor. The other one is just, when you're in a different state of mind a little bit on your test, it feels different. And reading comprehension in particular, We actually have a couple great stories on our website from tutors. These are people that score, really close to perfect scores. They're within one or two questions of a perfect score, 790 on the old version of the test, that sort of thing, who've walked in the test, gotten anxious, and go, I can't read this passage. We have a novelist, she's amazing, who had a meltdown, spent 9 minutes on a passage, and it looked different to her. She was nervous, right? So sometimes that sensation is just nerves. Sometimes it's maybe you over drilled certain things. It's like, hey, if you hyper focus on a handful of problems, the GMAT gets creative, you see a different one. That could be another factor. But in all likelihood, this might be over reliance on non-official materials. It might be just not seeing enough related, not seeing enough breadth of official questions. And third is, yeah, if you're anxious on your test, and about 70% of people are, it really can feel different when you're under time pressure. It's test day, and that is a totally normal feeling. So that's really, really common. Obviously, a lot more we could say about what might have gone wrong, but that's the highlights. Okay. All right. Run out of time a little bit here, but these are great questions. That's why we do this live. I love to address what you guys have in mind. Let's hop into this, not that one. Talked about this. Asteroid collisions, harder passage, I think. We're not going to get through all the questions in it. 2 paragraphs here. We'll go through the two paragraphs one at a time, and then probably get to one or two of the questions. I'll shut my mouth now. If you need more time, as always, hit that pause button. Yeah, Cesarino. Yeah. I warned you. I'm not messing around. I'm pulling the densest walls of facts I can. Some of these are really hard to get through. If you happen to like this stuff, sometimes it'll connect, sometimes it won't. What are we trying to do here? How do you fight through it? How do you find some structure when it's just like, whoa, walls of fact? Hey, I've got like asteroids. How do I give myself something to anchor to? That's what this is all about. I think there's something here once again. Before I hop into this paragraph, good question here from Pooja. Great to see you as always. So what I was saying earlier about non-official questions, sometimes giving you that feeling that the exam is different. So is it okay to do non-official questions? Yes, but you don't want to do them completely at the expense of official questions. That would be one comment. And sometimes I see people who just drilled and drilled and drilled off of a particular prep program, especially when it's just one prep program. And 90% of the questions they did were off of test prep company X's course or books or whatever. And then they get to the test, and of course the style is different. So that's more what I'm talking about. Is there value in those non-official questions? You bet. Verbal, it's notoriously difficult for companies to create realistic questions. It's really hard to mimic the style. Of our 10 or so tutors, we have 3 novelists, and we have a 4th person who almost published a memoir, had a literary agent, and met with the head of publicity department. Like, we have 4 amazing writers out of our 10. The others are all pretty good too, and we really struggle. So it's really hard to do. Quant, a little bit of a different story. Sometimes you need reps on whatever, percentages, ratios, rates, whatever it might be. And I think it'd be really good for that. So as a drill, as a way to learn, you bet non-official questions certainly have their place. As the mainstay of your diet, careful. That's part of what can lead to that feeling of, whoa, what is going on in this test? Okay, great question, Pooja. Okay, into this little paragraph. Excuse me. So it just launches right in, asteroids collide, and some of the collisions cause them to spin faster. Sometimes they slow down. And then we're talking about types of asteroids and how do you make sense of this? What I see here is there's really two possibilities for what asteroids really are, or types of asteroids. And as I kind of sit back a little bit and squint at this, I go, okay, wait a minute. I don't see any opinions. I don't see any points of view. And I'll say it again, that's rare on the GMAT. That's what makes this hard. But I do see, well, wait a minute. Okay, there's one possibility. If they're all monoliths, if they're all small rocks, or sorry, not small rocks, single rocks, here's what happens. If they're all rubble piles, here's what happens. And then they give us some more data. You got to make sense of that. Okay, so I'm going to anchor to that thing where the author is saying there's 2 possibilities. And honestly, it'd be kind of nice if the author said that in the first sentence or the second sentence, instead of we have to kind of pull that out. Again, that's part of what makes it hard. You've got to find the structure and really fight for it. Okay, so we have 2 possibilities. So possibility number 1, if they're all single rocks, what would we see? Well, if we were looking at a graph of the rotation rates, we'd see a bell-shaped distribution. We'd see a nice little bell curve. And so we'd have some that rotate fast and some that rotate slow. Okay, I'm going to draw a really bad picture. So this is what the rotation rates would look like. Okay, fast up here, low down here. All right, that's possibility 1. What if they are rubble piles? Then we wouldn't have this tail. There wouldn't be fast rotators, is what they're saying, right? Because anything, if it was spinning any more than once every few hours, it would start to fly apart. So if it's a rubble pile and it's just kind of a collection of rocky stuff, then that distribution is going to look like this. Bonk. Where there is no fast. Nothing's fast, right? The fastest tail. Okay. And then we've got this thing kind of tacked on at the end, and it's you got to work a little bit to make sense of why it's there, I think. So they've discovered all but 5 observed asteroids obey a strict limit on rotation, and the exceptions are small. And well, what does that tell us? That tells us that, I think that's telling us that it's mostly this, because we don't have a lot of the fast ones, but there's a few out there, right? There's tons of asteroids, presumably, running around in the solar system. How many have we observed? I don't know. But it's saying that they're all but 5 observed asteroids. So we only have these 5 asteroids. They're pretty rare. So the researchers are saying all but 5 observe the speed limit. And these 5, they're small, which makes sense. That kind of makes sense with the theory a little bit, right? Maybe we have 5 monoliths here, single rocks that are speedy, and the rest are rubble piles. That would make sense. It doesn't say that, but that seems to be where it's headed. That usually we've got rubble piles, but what's up with the exceptions? Okay, do I know exactly where the author's argument's going? I do not. I'm not that smart. I can't read the author's mind yet, but I do see structure. They're setting this up to say, hey, there's 2 different things that are possible. I've got to wade through some details, but I see some structure now. Okay. All right, any questions from the group? Awesome, Maria. Great, Maria, really like it. Okay. Wow, watching the 2017 videos. Look at this gray hair, man. I've gotten a lot grayer. Thank you so much for joining live. It's always fun. If you guys have friends, about 15 minutes left in the video. If you have friends who are studying, please invite them live. I love this. I don't like talking into a camera all by myself. I feed off of you guys. Please bring your friends. If you know anybody who's studying Fridays, we're going to be here Fridays for a while, a couple more reading comps, bunch of critical reasoning. Okay, second, final paragraph. Go ahead and take a minute. Really focus on anything you can anchor to in terms of structure. And how does it connect to this first paragraph? Go ahead and take a moment. Right, if you need more time, as always, hit that pause button. And I'll say it again, probably because somebody always asks in the comments later anyway. These are hard. I'm giving you about the hardest stuff I can find. This is tough to wade through. Live group, I'd love to keep lobbing your comments in there if you've got any, even if you're just kind of waving the white flag and saying, I'm stuck here. Okay. Again, one of the, it's not a secret, it's not a trick, it's just good hygiene, good practice on reading comprehension. The more you can anchor yourself in whatever structure you can find, even when we've got the gnarliest, least structural passages that exist. Okay, the author set us up with this sort of two possibilities for what asteroids are. We've got single rocks. Here's what they would do. You'd have some fast spinners. Rubble piles, we wouldn't have the fast spinners. What we observe out there is there's only 5 that are super fast. They're all small. And all the rest, there's a strict cutoff of the speed. So, okay, those are probably rubble piles. Okay, and then we finally see a little bit of the author's opinion, the evident conclusion. That's interesting. Is it consequential? I don't know, but the author's not saying this is right. The author's saying, well, the evident conclusion, what we think must be true based on this. I think it's interesting, right? The author isn't taking a stand and saying the definite conclusion. It's the evident one. Okay, not a big deal, but interesting. That the big ones are rubble piles. Okay, well, that's the evident conclusion. Big ones are rubble piles. Well, that agrees with modeling. I'll just say agrees with the computers. What else do we know here? Then the rest of it is detail-based, and if you struggle to get your head around it, I think that's okay. But I'd fight here to kind of just tell yourself the story. Do you understand what's happening when they say, well, the big ones are all rubble piles? Well, why is that? Why is it that the little ones? So we have the evidence that suggests that that's true, but how does that work really? There's collisions all the time, right? So asteroids are constantly getting knocked into each other. That's what the passage is telling us. They get blown to bits. Um, Literally, a collision can blast a big asteroid to bits. But what happens? They move slower than their escape velocity, so they're not flying away. The gravity is going to pretty quickly over a few hours, several hours, reassemble them into rubble piles. Okay, when does that not happen? Well, when an asteroid gets hit and the fragments are little, and that main piece of the small asteroid doesn't have very much gravity, right? So when you have a big asteroid and it flies apart, well, there's still enough gravity there, it recongeals. When it's a little guy, not so much, right? The little pieces just fly off because the little asteroid doesn't have the gravity to hold everything in. Okay, so after the collisions, so we'll say the big asteroids, we just say that gravity creates piles. These are the big ones. And the small ones, weak gravity, particles escape. Okay, am I now an expert in asteroids? I am definitely not. Do I feel like I understand this completely, 100%? I don't think so, no. Do I understand it enough? Do I understand where the author is going? Do I understand how the first paragraph and second paragraph connect? I do. I feel pretty good. Am I ready to tackle a question? I am. I think we're only going to get to one question, maybe two. I'll do my best to fly through this quickly before the hour's up. All right, I'll move pretty quickly here. Pause if you need to. Yeah, another great case of if you're nailing the process up to this point, investing properly. Notice how quickly we can go through the question. Where does time go to die in reading comprehension? It's on the questions. Because you didn't extract enough from the passage, then you've got to go back and forth, back and forth, back and forth. But because we took the time to dissect, think structurally, not so bad. Passage implies which of the following about the 5 asteroids. I mean, we know they've got to be these little guys, right? They're the little ones that are probably single rocks. They're the only ones that they've observed that are single rocks. That's kind of what the whole thing's saying. So yeah, A, the rotation rates are approximately the same. Don't know that. B, they have undergone approximately the same number of collisions. Don't know that. Those are happening all the time. C, they are monoliths, single rocks. Ooh, that looks pretty good. D, they are composed of fragments that have escaped the gravity of larger asteroids. Nope, probably not. Because again, these little guys, those 5 observed asteroids, they're the ones that are spinning super fast. They got to be little. They're all by themselves, not D. E, they were detected only recently. Who knows? Maybe they were, maybe they weren't. We don't know anything about that. And C is our answer. And by the way, most people got obliterated by this question. Live group, some of you are struggling, but most of you are getting it. So again, success on the questions isn't about staring your eyes out at the questions. If you're doing that, if you find yourself routinely spending 2.5, 3 minutes on a single question, it's a sign that you need to invest a little bit more in processing the passage, making connections, making sense of it, finding the structure, finding the point of view. Okay, we got time for one more. Tough one. Most people miss it, a majority. So if you struggle, please don't be sad. Awesome. All right, pause if you need to. Live group, and again, I know it's a limited little data sample here of people who choose to answer in the chat, but it's kind of cool because I'm seeing some of the same names week after week, and I'm seeing your answers and the way you frame things. I'm seeing it change for the better, and it's pretty cool. So discovery of which of the following would call into question the conclusion mentioned in the highlighted text. What is that conclusion? That's the whole thing we were talking about in the second paragraph, really sort of in the first two. It was set up by the first. That evident conclusion that the big ones are all rubble piles. What do you know about the rubble piles? Well, the rubble piles can't spin that fast, right? What do we? So, in the smaller asteroids are more likely to be single rocks. The single rocks can spin at any speed. Okay. With that, as you look at A and B, would that conclusion be invalidated or called into question by A or B? Well, not at all, because those little asteroids can spin at any speed they want, right? That doesn't challenge the theory at all. The only thing that would challenge the theory is if we have some fast spinning big guys. So A and B we can knock out right away because those little guys can spin, those little guys, those single rocks, they can spin at any rate, not a problem. So A and B are out. I don't even have to worry about exactly what those speeds are. Okay, from here, I'm not gonna lie, you guys. First time I saw this question, maybe the second time as well, several years apart, I was like, wait, but what speed is considered fast? What is that cutoff? Because I had to go back and find that in the first paragraph, that if it's spinning faster than once every few hours, then it would fly apart. So what does fast mean? What is that cutoff? We don't know exactly, but it's somewhere around once every few hours. With that, these three big asteroids in C, D, and E, which one is going to call into question the conclusion? It's the fast spinning big asteroid bigger than 200 meters. C, 250 meters spinning slowly, no problem. That doesn't call the conclusion into question. D, 500 meters, big, rotating once per hour. That's faster than once every few hours. That's fast. That's a problem for the theory. And E, an asteroid at 1,000 meters, big, rotating slowly. No, the big ones can rotate as slowly as they want. That's not a problem. E is out. It's only D that would call into question that conclusion because it's a big asteroid rubble pile spinning faster than once every few hours. Okay, that's it. Thank you for making it to the end of the video, you guys. If you have friends, please invite them live. Next week, I think we're going to tackle humanities, culture, legal passages. So kind of the analog to this video, I was giving you the hardest wall of fact science passages. I'm going to give you some of the really intimidating, esoteric, legal, not things we necessarily talk about every day. That'll be next week. The following week, I think I'm just going to fire. I think we're just going to do a video on the very hardest passages. Maria, thank you so much. I really appreciate it. Awesome to see you here week after week. Really cool to see the growth. That's why I teach for a living. I really enjoy it. And then after that, we're going to launch into critical reasoning. So if there's particular pain points in critical reasoning, let us know in the live chat the next couple of weeks during Reading Comp. Let us know on GMAT Club. Tag me at GMATNinja on GMAT Club. Tag me on YouTube at GMATNinja Tutoring. Let us know what you'd like to see. We respond to you. This is for you. Please bring your friends live because I love the energy. All right. Thank you so much, everybody. Have fun studying, and we'll see you next week.